All right, so today we're going to be talking about dosages and calculations. You all hopefully are going to be nurses soon, and medication dosages and calculations, something that you have to know, is something that we do all the time. Let's give everyone just a few more seconds. I hear that beeping in my ear when people are waiting in the waiting room. All right. So dosages and calculations, what we use to measure medications is the metric system. And we have to be able to compute these medication dosages accurately every time for every patient. So when we're giving medications, we want to be sure that we're organized. We want to be sure that we have everything that we need, and that we use an organized system to administer medications. So we use a metric system, and I know that you all are aware of that because you've had your first dosage and calculation test, but I'm going to tell you a little bit about why we use that metric system, because this metric system is organized into units of 10, and it makes it really easy to compute numbers when they're organized in this manner. It makes it easy to convert and work your way through multiplication and division, okay? However, it's very important when you are converting your measurements that you do not misplace your decimals when you're using your metric system. Guys, take you back. All right, so when we're using the metric system, we usually work in meters, liters, and grams. Those are going to be the ones you use quite often, in milliliters as well. And then we also have another way to measure medications, and that is our household system. The household system is really familiar with everyone, but we also know that the household system is inaccurate. Grandma would say, okay, let's go in here. I was looking in the chat and Eric says some of us are old and slow. I'm not sure what he's referring to. All right, so the household system is, you go in the kitchen, grandma decides that you need some Robitussin, you have a cold, she goes in her silverware drawer and pulls out her tablespoon, she pours you some Robitussin, and hopefully you feel better, right? But we all know that the tablespoon is going to depend on which grandma kitchen you're in, okay? So those sizes are going to differ depending on who manufactured that spoon. So that's why household measurement systems are usually inaccurate. We don't really use those. So we got a kick out of this when we first had to quarantine. We don't like using the metric system so much that we said, how much is 6 feet? It's about an alligator's width apart, okay? So let's get into this metric system. The metric system, you have kilo to the left, hecto, deca. Usually your unit of measurement is in the middle. You see right there under the U, you have gram, liter. So this is your starting place. You usually start at the U, and that's why it's big like this, okay? Then to the right of the U, you have deci, centi, milli, and micro. Now, what you notice that these prefixes are usually identified in multiples of 10, right? When they're being used. If you go to the left of your unit, does the number get larger or smaller? You can type your response in the chat. Yes, the number gets larger as you move to the left of that unit. And if we move to the right of the unit, the number gets smaller. That's where we have our deci, centi, milli, and micro. All right, so this is just showing you basically that if we start at grams and we are trying to get to micros, how many measurements, unit measurements, are in between gram and our microgram? It's going to be 3, right? There's 3 places in between gram and then our microgram. So basically this is saying in 1 liter, you're going to have 1,000 milliliters. In 1 milliliter, you're going to have 1,000 microliters. 1 kilogram, 1,000 grams, 1,000 micrograms in 1 gram, and then 1 microgram is equal to 1,000. 1 milligram is equal to 1,000 micrograms. This is something you have to know, guys. You might as well go ahead and highlight it and write it down, because we use these conversions to move back and forth when we are doing our medication dosage and calculations. So this is something you have to know. So apothecary is an old-fashioned way of measuring medications. We really don't use it anymore because it's unreliable. However, we have found some metric equivalents to these apothecary measurements. So you see at the bottom of this slide where it says commit to memory. This is another few conversions that you just have to know. You have to know that in 1 fluid ounce, there's 30 milliliters. In 1 teaspoon, there's 5 mLs or milliliters. 1 tablespoon is going to be equal to 15 milliliters. 1 cup, 240 milliliters. 2.2 pounds is going to be equal to 1 kilogram. Can you tell me what measurement is not in this chart? Which measurement is left out? We have volume. So gallon would be a volume. Yes, height is not there. Length, very good, Stephanie, Ashley, length. So just know in this graph, you're going to have your volume and your weight measurements, but your lengths are not there, okay? All right, so grab your scratch paper, and we're going to give you a problem. How are you going to solve this? Your order is you have 100 milligrams of drug A. And what you have on hand is 50 milligrams per tablet of drug A. Hold off on your answers, hold off. How many tabs will you need to give the patient? And yes, I know that you can do this math in your head, but what I want you to do during this lecture is to use dimensional analysis to answer the question. Well, I know that there's many ways to come up with this answer. The way I've learned it and what I use to stay organized is dimensional analysis. So how does it work? We are looking for tablets. So that's what we're going to start with. We're going to start with tablets. And what I like to do is say X tablets, because I don't know how many yet. Well, some of you do. But I'm pretending that I don't know how many tablets. So X tablets. What I need on top is what I'm trying to solve for. So the next number you want to put in is what you have on hand. And what do I know? I know that one tablet has 50 milligrams in it. So how am I going to write that? I am going to write 1 tab over 50 milligrams. And the next thing I'm going to do is bring the fraction over that can cancel the previous one. So it's kind of hard to see how these are lined up in this slide, but your 1 tab is your numerator, so your top number. Your 50 milligram is going to go on your denominator. So then you're going to look at what you have that's ordered and what can I cancel out. If I look at my order, I know that I have 100 milligrams of drug A. So if I put the 100 milligrams on the numerator and my 1 on the denominator, what cancels out? Can you type that in the chat? What's going to cancel out? That's correct. Your milligrams are going to be canceled out. And then what are you left with? Yes, you're left with tabs. So you're going to cancel out those units of measurement. And then you're just going to do your math across. And you should end up with 2 tablets. And I love this little cloud around my answer when I have arrived to nirvana. Right? Let's try another one. So when you are doing medication calculations, be sure that you are taking your math over to another nurse just so she can verify it. And that's another reason why I like to do dimensional analysis, because if there's an area where you made a mistake, usually it's more likely to be seen when you use dimensional analysis. All right, so in this problem right here, it's asking you how many milliliters do you need to give to fulfill this order? So what do we know? We know we're looking for milliliters. So when you set it up, it should look like this. What I have available is I have 1 milliliter, and I know that 1 milliliter is equal to 20 milligrams. And then what do I have ordered? I have 40 milligrams ordered. So we're going to cancel out, and what do we do? Yes, let's divide. X is going to equal 2 milliliters. If you're following me, just type yes in the chat, please. Lots of yeses. Too fast. Okay, I'll try to slow down. Okay, good. All right. I'm just going to leave this up here, and what I want you guys to do is go ahead and set up your problem. If you get an answer, do not type it in chat. Let's allow for everyone a chance to solve for the answer. What you have ordered is augmentin, 500 milligrams by mouth daily. What is available is 250 milligram tablets. Your question is, how many tablets will the nurse administer? So the first thing that you're going to do is place your X, because we're solving for tablets. So X tablets. We know what we have available. 1 tablet has 250 milligrams in it. So our 1 tab is going to go over in the numerator, and our 250 milligrams is going to go in the denominator. And what is our order? It's in green in this question. The order is 500 milligrams by mouth daily. So what are we going to put in the numerator? We're going to put 500 milligrams. And now you see that we can cancel out this milligram on the top and the milligram on the bottom. So now we're going to multiply. And everyone type in the chat box what the answer is. Good, 2 tabs. Stephanie, are you with me? All right. So we have our 500 tabs divided by 250, and that gives us 2 tabs. All right, here's another one. I'll let you guys set it up. The order is to give 100 milligrams of Tylenol by mouth. What I have available is 250 milligram tabs. How many tabs will I administer? This is one you probably could figure out in your head. But I would like for you to work through the problems, because the more you practice setting up these problems, the better off you will be when you run into more complex math problems. So we have to get a strong foundation of how to set up these problems. So when you have longer complex problems, you know how to pull information from the problem or the question and plug them in accordingly. All right, so X tabs, 1 tab is over 250 milligrams. What is ordered is 100 milligrams. Our milligrams is going to cancel out. And that is right. I see my answers rolling in. 100 tab divided by 25. And X is equal to 4 tabs. Very good. Just this chat box real quick, get it out of my way. All right, so this is just some common metric measurements. I told you guys, when you are using these units, you need to be very specific in how you abbreviate them. For instance, if you're talking about milligrams, you need to be writing milligrams a certain way. Milligrams is always written as mg, and usually it's lowercase. Milligrams and milliliters always going to be lowercase. Sometimes you may have grams and liters, either with a capital G or a capital L. But the thing to remember is that using fractions is not allowed when we are doing these dimensional analysis questions. And if you are using your decimal point, be sure that you are always putting a 0 before the decimal and never after. So if you have 0.25, it needs to be written as 0.25. If you have 25, it needs to be written as 25, not 25.0. So always zeros before the decimal, never zeros after the decimal. Just a little trick that we use. You might remember this from when you learned how to convert in high school. King Henry died usually drinking chocolate milk. That's a good way to know which way you're supposed to go. You already told me that if I go to the left of my unit, then my number is going to get larger. And if I go to the right of my unit, my number is going to get smaller. I talked about this a moment ago. Usually with grams, you're either going to have a little g or a gm. With liters, See, liters are always just one uppercase L. Can you all tell me why I would not want to write a lowercase L if I'm working with liters? That's right. If I'm talking about liters, it can be transcribed or mistaken as a 1. And yes, I want to avoid confusion, because the less confusion when I am doing these medication dosages and calculations, the better. The dimensional analysis is already enough to worry about, so I don't need any more confusion. So from now on, when you are writing out these abbreviations, if you're talking about milligrams, it needs to look just like the milligram abbreviation that you see in this slide. It needs to be a lower M and a G. Now with milliliters, you see how I have a lowercase m and an uppercase L. That's usually how we write it. We do not use CC. Now, we don't write CC. Every now and then you'll hear someone say, if they're an older nurse, such as myself, you will hear them say 10 cc's. So if you're going to have clinical with me and you hear me say, go grab me a 10 cc syringe, then what I am asking for is a 10 milliliter syringe. But when we are writing these measurements out, although I say cc, I don't write cc when I am referring to milliliters. And I talked about the fractions. We're not converting fractions to decimals. What I mean by that, if I have 500 milligrams or if I have 0.5 grams, I am not going to write that I have 1/2 a gram in a fraction. I'm either going to write I have 0.5 grams or I have 500 milligrams. And that's the same with milliliters. Remember, no trailing zeros. So if I have 5, I'm just going to write 5. And then my unit, 5 tabs, 5 milliliters, 5, whatever it may be. So no trailing zeros. However, my 0 in front of the decimal, I'm always going to put it there. So always use your 0 in front of the decimal. All right. So I want you to, let's just do dimensional analysis to solve this problem. How many milligrams is 300 micrograms equivalent to? I just want you to convert milligrams to micrograms using dimensional analysis. And I'm going to give you a moment. So what do I know? I am looking for grams. What do I have available? I know that 1 gram is equivalent to 1,000 milligrams. $300 milligrams over 1. My milligrams are going to cancel out, and then I'm just going to divide. So we have 0.3 grams. Is it okay for me to just write 0.3 grams? Type your answer in the chat. I like that no with an exclamation point. No way. Excuse me. That is correct. No way. We have to write 0.3 grams. because we don't want any confusion. We don't want to give any room for anyone to misread what we've written. So here's some other units of the household measurement system. We have weight. We measure weight usually in the United States by pounds. Our volumes that we're going to use, we're going to have cups, teaspoons, and tablespoons. And the length, usually we measure length in feet and inches. So what does that look like when we are doing conversions? Tell me, how many milliliters are there in 1 fluid ounce? Right, we can obviously look at this cup and see that there's 30 milliliters in 1 fluid ounce. It's pretty apparent that that's what's in there. So that's what I want you to know, that you have to compute or remember, commit to memory those apothecary measurements that I told you about. Be sure you write those down. You have to know those. What I want you guys to do is solve for milliliters. Do not put your answer in the chat until I ask for it. I want you to set it up using dimensional analysis. How are you going to set it up? We are solving for milliliters. So I'm going to write X milliliters equals. What am I going to put on top? What can I pull from this question that is going to allow me to solve for X milliliters? There's nothing there actually. So we are going to have to know this conversion. And what is the conversion? We know that 240 milliliters is equal to 1 cup. That's right, 240 milliliters is equal to 1 cup. And then I say, okay, now I can pull from this problem to help me solve for milliliters. And what do I have on hand? I know that I have 2.5 cups. So my cups are going to be canceled out like that. And then I'm going to multiply. So Stephanie, if I take this slide back, I'm going to try. On the previous slide, remember I told you that there are measurements that you have to compute to your memory. Those apothecary measurements that kind of just are equivalent to the metric system. That's where I got that answer. I have to know in my mind that 240 milliliters is equivalent to 1 cup. I just have to know that. In this problem, it's not going to give me that because that's something I should know. So I'm multiplying across. I have 600 over 1. All right, and my answer, 600 milliliters. So I have a question for you all. Why might I want to know how to convert cups to milliliter in a hospital setting? What am I even going to use that for? Yes, I see for my intake and output. If I have someone that has a Foley catheter on my bag, it might be pretty easy to go up to that Foley catheter bag and look at the urometer and say, okay, there's 500 milliliters in here. But what if I have a person that's on strict I's and O's and they come to me and say, you know what, my mouth is really dry. Can I have a cup of ice chips? And that ice starts to melt, it's going to turn into a liquid. And I don't know how many milliliters that I've given them. So that's why it's important to know the equivalent of cups to milliliters, because when I go to document the I's and O's at the end of my shift, it's not going to ask me for, oh, well, how many cups of water did you give your patient? It's just going to say how many milliliters of input and how much output. So I'm going to give you guys a moment to set this up. Use dimensional analysis to set it up. So do not let this problem trick you. You're always going to look for the information you need to answer the question. So using the dimensional analysis will help you figure out what you need in order to solve the equation. Can I go ahead and proceed? All right. We're solving for milliliters, right? So how many milliliters would the patient need per dose? So we're going to say X mLs equal. What do we know? What do we know? What are we going to have to use in order to solve for milliliters? Very good. I have to know that 1 teaspoon is equivalent to 5 milliliters in order to get over to my next conversion. So I know that 5 milliliters is equivalent to 1 teaspoon. Now I can get to doing my work. What I have available is 1 teaspoon over 250 milligrams. What's ordered? I can cancel out my teaspoons now that I have one on the top and one on the bottom. I can cancel those out. So what can I pull from my question in order to answer this question? I know that I have 5 milligrams ordered and I put that over 1. So now I can cancel out my milligrams. That bottle with the 50 milliliters of augmentin, that is a distractor. Do not let it fool you. It's there to throw you off. But you can see these types of questions in NCLEX style questions, especially the math questions. They love to throw in distractors. So using your dimensional analysis will help you to avoid those distractions. Someone said it successfully distracted them. Yes. but you're better than that distractor. So you just ignore that distractor and compute what you know. But the big thing is knowing how to cross over. And what I mean is knowing what conversion to use to get to solve for your milliliters. So after we do all our canceling out, we multiply across, and that leaves us with 10 mLs. Did everyone get 10 mLs? Oh, I see some different answers. Okay. All right, good. Here's another one. I'll give you a few minutes to set it up. We know that we are solving for milliliters. What is available? We have 2 milliliters and 0.5 grams. But in my order, it states that I have 200 micrograms of Cantrex. So how am I going to get to milliliters? What do I need? I need a conversion to get me over to my milliliters. So I know that 1 gram is in 1,000 micrograms. I know that. That's one of those things that I'm just going to have to know. The problem is not always going to tell me my conversion that I need. So now I can cancel out my grams. And now there's an opportunity for canceling out my micrograms by plugging in my 200 micrograms over 1. My micrograms cancel out, and now I can just do my straightforward math. So I'm going to multiply across, gives me 400 over 500, and it leads to my answer of 0.8 milliliters. Okay, what's your question, Derek? Am I saying micrograms? If I am saying micrograms, I apologize. I mean to be saying mg. Milligrams, not mcg. How do we know what needs to go on top? And I apologize for saying micrograms. I mean milligrams. Sometimes my brain works faster than my mouth. And so I moved on to something. And sometimes I just say stuff that's not right. And in this case, I'm just saying something that's not right. I meant micrograms. Okay, so how do you know what needs to go on top? So if you think back to the beginning, I want to be able to put what I am solving for on top. So if I'm solving for milliliters, I need to find that same unit of measure somewhere in my problem or somewhere stored in my brain by way of conversion. And that's the unit that needs to go on top. Does that make sense? Derek? Okay. So if I'm solving for milliliters, then I want, after my equal sign, I need the milliliters to be in my numerator, which is my top number. If I'm solving for tabs, I need tabs to be in my numerator, which is my top number. We're going to do some more. All right. Now, when you all go to lab, when you do simulations, we're not going to give you, or they're not, sorry, lab instructor mode, they're not going to give you a straightforward math question. What you're going to have in front of you is a drug. You're either going to have some sort of IV solution or some sort of medication physically in your hand that you're going to have to know how to plug the answers into. So in this slide, let's see if I can get my pointer to work. Okay. Oh, there we go. You see we have a medication label here. Now this medication specifically is your atropine. We don't have to know what atropine is just yet, but for purposes of today, we just know that it's atropine. But what I want you to hone in on anytime you pick up any medication is how much drug is in this bottle bag per volume. So in the chat, tell me how much medication is in this bottle. Okay, can you all see my laser pointer? Just someone type yes. Okay, your answer is right here. What this medication label is telling me that in this bottle, I have 0.4 milligrams in every milliliter. So what is the total amount of milliliters that the bottle holds? Very good. Yes, the total volume in this bottle is right here, 20 milliliters. But what I know is that there are 0.4 milligrams per milliliter. Now, I think some of you, if you look down here, it's kind of hard to look sideways, but if you look at this label right here, it's telling you some approximate equivalents. So tell me how much medication, by way of the chat, is in 0.4 milliliters. Very good. 0.16 milligrams. So now that you know how to read this label, I want you to tell me how many milliliters will you administer for 1 milligram of atropine. Very good. No, Stephanie, it is not always on the bottle. This was just a way for me to show you all how to use a medication label. So it's not going to always be on the bottle. But the point in this question is to get you guys to looking at your label, because sometimes there is more information on the label that we need to know. All right. So if we're solving for it, what do we know? We know that 1 milliliter is going to be equivalent to 0.4 milligrams. And what is my order? My order is for 1 milligram. You guys see that? You see how I set that up? What I did, if I'm solving for milliliters, my medication label tells me that I have 0.4 milligrams per milliliter. So I'm going to put what I have available right here. And then I'm going to put what is ordered right on that side. And then I'm going to cancel them out. And that gives me my 2.5. Very good. Do I have any questions about this? Okay, I'm going to take that as a no. So now we're going to talk about calculating weight. In the chat, tell me why we might have to compute or calculate weight as a nurse. Very good, because some meds are weight-based. Some meds are very specific. If you weigh 100 pounds, I'm going to give you 7.5 milliliters or milligrams of a drug. Okay, so for weight-based medications, we have to know how to convert pounds to kilograms. And that's one of those golden conversions that you're just going to have to compute to your memory. 2.2 pounds is going to be equivalent to 1 kilogram. If I were you, that slide that I told you to commit to your memory, I think it's slide 6. I will go ahead and make another copy of that. And be sure you know it. Now, when we're talking about weights, we are going to round to the hundredths place before you continue on with the calculation, right? So I want you all to convert 120 pounds to kilograms. I'm going to give you a minute to set it up. 120 pounds to kilograms. Now, do you see what I mean by rounding to the hundredths place? So you have 54.55 kilograms. If I was going to take my weight in kilograms and place it into another conversion or problem, I would have to go ahead and round that up. So if I'm rounding to the hundredths place, what would be my answer? Crystal, you're fast. You see where I'm going here. So what is my answer when I am rounding up to the hundredths place? 55 kilograms. Very good. Now, we talked about calculating intake and output, but I want you to know that it's usually measured in milliliters. The I's and O's may require some conversions, and you see down there in that box, I put our golden must know conversion box right here. You just have to know these. There's no way around it. If you can really commit these right here to your memory, the easier your life will be. So knowing these conversions is going to help us navigate between those household, apothecary, and metric system measurements better. So I'm going to give you an I know problem. Maybe. All right. What I want you all to do, I want you to calculate the intake. Do not type your answer in the chat. Calculate the intake. When you are ready in the chat, say ready. Type ready. Trying to give everyone enough time, because I know if you're like me, it's hard for me to work a problem by someone reading the problem to me. I have to read it myself. And seeing lots of readies. Ready? Okay. So we have 4 cups of water. And that's one of those golden conversions. I have to know that 1 cup is equivalent to 240 milliliters. So if I had 4 cups, I'm going to multiply 4 by 240, and it's going to give me 960 milliliters. I have 500 milliliters of broth. Yes. 750 milliliters of urine. That's output. I hope your patient is not going to be drinking 750 milliliters of urine. If they do, you're going to have a problem. Okay, so our other input is going to be, yes, my normal saline. 1 liter is equal to 1,000 milliliters. And 30 ml of wound drainage. Anytime we talk about drainage, that is output. So now I want you all to tell me, what is my total intake for the shift? Yes, very good job. 2,460 milliliters. There's my intake. Now I want you all to calculate the output. If you're ready, say ready. All right. Don't let this question fool you guys. Although we're very curious about what D5W is. D5W is a solution that is saturated with sugar, dextrose. Okay, so it's dextrose and water, D5W. Usually it's dextrose 50 and water. It's an IV solution. Yes, Ashley, it's an IV solution. But even if we didn't know what dextrose was, is that intake or output? What's going to give it away is if you see anything at like milliliters per hour, usually that's something we have to program in an IV pump. So we know that that is going into the body. So if we're just looking at our output, we have 600 milliliters in the Foley catheter bag that is coming out of the body. So that is output. We have 200 milliliters coming out of drainage from our JP drain. And we have 400 milliliters of loose stool. So what is my total for my output for my shift? Very good, 1,200 milliliters. Now, I want you guys to calculate the intake and the output for your entire shift. If you are ready, type ready. We'll give you a few more seconds. All right. So we know that our patient had 2 popsicles that consisted, of 12 ounces per popsicle. And what's our golden conversion for figuring this out? What do we know? Type it in the chat. What's going to help us? Good. We know that 1 ounce is going to be equal to 30 milliliters. Good. All right. So we have that times 2, and that gives us 720 milliliters. Our IV fluid, we have 125 milliliters per hour, and it's going for 10 hours. So we're just going to take 125 and multiply that by 10, and that gives us 1,250 milliliters. We have 350 milliliters of stool, so that should go in output. If you're having a good day and a good shift, that will go in output. We have 2 16-ounce apple juices. So what do we need to know? There it is again. We need to know that 1 ounce is equal to 30 milliliters. So that's going to give us 960 milliliters. We have 1,460 milliliters of urine. That is output. And then we have this thing here at the bottom. We gave 10 milliliter IV flushes 5 times. If you're wondering what an IV flush is, it's just this syringe that's usually filled with normal saline, and we flush it to keep the IV patent, to keep the IV open and running. And so we have to count those flushes. A lot of people don't think about IV flushes, but if you're adding any fluid to the body, then we have to count that as intake. Something as small as an IV flush does have to be factored in. So that gives us 50 milliliters. So our total, now what I want you guys to do is give me the total intake for your shift. Type that in the chat. Good. Very good. You just go down and you add it all together. And what is our output for the shift? Now, I know you all probably thinking, oh my gosh, do I have to do this? Really? And the answer is yes. Every time you work a shift, at the end of the day, you have to go through and be sure that your intake and output has been recorded on every patient. And you have to go through and you have to clear out all your IV pumps to know exactly how much it has infused in your patient. So this is actually something that we do every shift. So you need to be very clear about what is intake and what is output. And as you all work your way through the semester, you will be clear, hopefully by the end of clinical. All right, military time conversion. Listen, when I was a new nurse, I struggled with military time. I was just like, I can't remember all these numbers. It's confusing. Like I did good up until 12 p.m. And then after 12 p.m., it was just like, I don't know what to do until some blessed soul told me that if you get to noon or 12 p.m., you just add a 1. So if it's 1 p.m., you would add 1 to 12. So 12 plus 1 is 13. If it's 4 p.m. and you're trying to figure out what the military time is, what are you going to add to 12? Type that in the chat. If it's 4 p.m. and you're trying to figure out the military time, what are you going to add to 12? You're going to add 4. 12 plus 4 gives you 16. So your military time is 1600. Yes. So it's just something that you're just going to have to know. Be sure that you don't put a colon because then that just gets really confusing. We can assume that we knew what you were talking about if we're giving you a written test, but if you're doing time in ExamSoft, just remember no colons. Here, let me get caught up with my papers. Right, these rounding rules. Now, rounding rules will be placed at the top of every math question for every exam. Every question. So be sure that once you come up with an answer, you go back and you double check your rounding rules. Double check your rounding rules. Remember, in order to obtain credit for your dosage and calculation answers, you have to follow the rules. So do not include trailing zeros. If you have a 5, it's just 5. It's not 5.0. If you have a 0.25, you have to put the 0 there, the lead-in 0. You can't just drop it. You can't write 0.25. It's going to be incorrect. Now, the unit of measure must be identified correctly on paper exams. But when you're in ExamSoft, it's just the number, okay? There's no way for ExamSoft to recognize like the unit of measure. Do not round numbers until your final answer, except for what? Which unit of measure do we round up? Yes, weight. Very good. Kilograms. You want, except for weights. So do not round numbers until your final answer, except for weights. You want to convert all your weights from pounds to kilogram, and then you're going to round to the nearest hundredth. If you have less than 1 ml, you need to have the lead-in 0. That's an easier way to remember it to me. If I have less than a milliliter, then I need a lead-in 0. If I have greater than 1 milliliter, then I just drop the 0. But if you have 2.45 milliliters as your answer, do you see why we round to the correct tenths place? So instead of having 2.45, we're going to have 2.5. It's hard to draw up in a syringe 2.4 fifths of a milliliter. It's just easier to go ahead and say 2.5. But what I want you all to remember is to follow the rules. Follow the rules. So remember, only write the unit of measurement if it is a handwritten exam. You're only going to put in the number in ExamSoft, not the unit of measurement. If you put 2 ml in ExamSoft, it's going to be wrong. Okay? It's going to be wrong. So follow the rules. Read your rounding rules for every question. Don't try to just skim over it. Go ahead and read it. Remember, we don't use fractions or commas. We only use decimals. Keep your lead-in 0. Drop the trailing 0. Now, if you all need additional, let me see if I can stop this PowerPoint before I go home. Are there any questions? Come on, stop sharing. Oh. No questions? Well, what I was going to tell you guys, if you need to practice more math questions, it's not wanting to get my book. Your dosage and calculation book looks like this. And it has tons of, okay, I give up. It has tons of practice questions for you in that book. But during your lecture with Professor Belknap, there was a problem in her slide that she wanted you all to solve. Remember, she asked you all if you had your first dosage and calculation lecture, and you were like, no, we haven't. And she was like, well, just remember to go back. So I wrote that problem down so you could solve for it. It was in her, oh my gosh, which lecture was that? In her analgesic lecture. It was slide 9. All right, so what you have on hand is 15 milligrams per milliliter. That's what you have on hand. 15 milligrams per milliliter. What you have ordered is 12 milligrams. So my question is, how many milliliters will you give? Very good. Yes, you will give 0.8 milliliters. So if you all don't have any questions for me, I don't have any for you. So you are free to go if you don't have any questions for me. But I'm going to strongly suggest you work the problems that are in the book that have the drug label. Remember, I showed you that atropine? Work some of those questions in your book because it will better prepare you for simulation and lab. All right. Thanks, guys, for hanging out with me today. You've been fun. There's not a page for the problems we went over today. They're actually in your PowerPoint. You are welcome. Ashley, you can stay with me if you want to. We can stay till 6. You all are welcome. You don't want to stay with me, Ashley? We can work some more problems together. Farm tests next week is in person, not on Zoom. You all might want to check your lecture schedule for first exam date. Yes, at Straw Plains. Exam will be at Straw Plains. Oh, let me stop recording. Might be a good idea.